Hey, so how about graphing this? Y equals secant pi x minus pi over 3 plus 5. Well, I've seen over the years a number of different ways to graph this function, and most of them suck. But one that I like, that I think you might like too, is step 1, graph the cosine version. I know this is secant, but I'm going to hold off on worrying about secant. Instead, I'm going to graph y equals cosine pi x minus pi over 3 plus 5. Now, heads up, if this were cosecant, then I would say graph the sine version. Okay? All right, so we know that we're supposed to start graphing this by setting the stuff in parentheses, by setting the argument equal to 0 and 2 pi. So I'm going to get pi x equals pi over 3. And when I divide both sides by pi, I'm going to get x equals 1/3. Over here, this is 4 pi over 2 plus 1 pi over 2. I'm going to have 5 pi over 2. And over here, pi x. If I divide both sides by pi, I get x equals 5 halves. 5 halves? Third? Did I miss something here? No, I didn't miss something here. Oh, yes, I did. I copied this wrong. That's why. So this is 6 pi over 3 plus 1 pi over 3, which is 7 pi over 3. And then when I divide both sides by pi, I get 7/3. Well, that's much better. I usually expect these to have the same denominator, and when they don't, it makes me take a second look at things. I encourage you to take a second look at things and think about what you're doing while you're doing it. Now, if that's not a life lesson, I don't know what is. Okay, 6/3 plus 1, 7/3. Good. So 1/3 and 7/3. Okay. We've got 1/3. We've got 7/3. Halfway is 4/3. Here we're going to have 5/6. And here we're going to have 11/6. All right, we added the numerator, doubled the denominator. Added the numerator, doubled the denominator to find these quarter points. Cool. Now, our cosine is a positive cosine, so I know cosine starts high and heads low and then back up again. Please don't make the V. Please don't make a parabola. Use the appropriate concavity. Okay? And then we know that this is y equals 5. Good. We're almost done. We just have to now apply the a value. Well, I'm going to go up 1. I'm going to go down 1. So this will be 1/3 6. And this will be 4/3 4. And this will be 7/3 6. Okay, so there's our cosine version. Now, step 2. Don't worry, there's only this next step and one after that, and we'll be all good and done. Step 2, where the cosine version equals 0, draw vertical asymptotes. Okay. Drawing vertical asymptotes where the cosine version is 0. See, 0, 0 was the cosine's zeros. And then step 3, and this is the last step, draw in, and the great word for you is paraboloids. There we go, loids. We've got paraboloids. So I'm going to have something that bends to that asymptote, that bends to that asymptote, that bends to those asymptotes. So the red stuff is the answer to the question, hey, what's the graph of secant pi x minus pi over 3 plus 5? In fact, you don't need this. And I would like you either to erase it or draw it as a dotted line, some sort of graphing aid. But really, our graph, these two asymptotes and these three pieces, kind of looks like a rational function, huh? Nice. So that's how we do secant and cosecant. Let's do that again once or twice more. Right. How about y equals 3 cosecant x over 2 plus pi over 4 minus 7. Okay, so, hey, it's a cosecant. Well, that just means that step 1, I'm going to graph the sine version. So we're going to graph y equals 3 sine x over 2 plus pi over 4 minus 7. All right. So we're going to set that argument equal to 0 and 2 pi. So over 2 plus pi over 4 equals 0. And x over 2 equals negative pi over 4. And if I multiply both sides by 2, I get x equals negative pi over 2. Don't forget we also need to set x over 2 plus pi over 4 equal to 2 pi. And so we're going to have x over 2 plus, subtract it from both sides. 8 fourths minus 1 fourth is 7 pi over 4. And if we multiply both sides by 2, we get 7 pi over 2. So we get negative pi over 2 and 7 pi over 2. Okay. Negative pi over 2, 7 pi over 2. Halfway in between, 3 pi over 2. How did I do that? I added the numerators. That gave me 6 pi, and I doubled the denominator. And then I can reduce. Ta-da! Okay. Now to find these quarter points, I'm going to have 5 pi over 2 and 1 pi over 2. So these are the critical points on my sine graph. Now we're supposed to graph a positive sign. Sine starts on the midline, goes up, down, back up. Okay, so there's our sine conversion. Remember what step 2 was? Step 2 said where the sine version equals 0, draw in vertical asymptotes. Oh, look at that. And step 3, draw in rhomboids. I think that should be a rhomboid. Go with A. Okay, so and the red thing with the 3 vertical asymptotes and the 2 red bits, this is our graph. Don't forget we want these points labeled. This is pi over 2, our amplitude, so this is y equals negative 7, and I go up 3, so that's negative 4, and here we have 5 pi over 2, this was negative 7, and we go down 3, so negative 10. Alright? Yeah, it's not so bad. Here, why don't you do another one? Why don't you graph this one? Y equals negative 1/2 secant x over 3 plus pi over 2 plus 3. Okay, so this graph is secant function. Don't rush, just give it the time it takes. Remember to start out by graphing which version? Okay, welcome back. So we know we're supposed to graph the cosine version. Oops. So over 3 plus pi over 2. Okay, so x over 3 plus pi over 2 equals 0. X over 3 equals negative pi over 2. And we get x equals negative 3 pi over 2. Cool. X over 3 plus pi over 2 equals 2 pi. That's 4 pi over 2 minus 1 pi over 2 is 3 pi over 2. And then I'm going to multiply both sides by 3. So I'm going to end up with 9 pi over 2. The negative 3 pi over 2, we've got 9 pi over 2. Okay, halfway in between. 3 pi over 2. And halfway in between these two numbers is 0. That's very nice. And halfway between these would be 6 pi over 2. Okay, so we're sketching in cosine. Ooh, it's a negative cosine. Remember, negative cosine starts low, goes high, and back down again. Again, these have appropriate concavity. Label your d, and then use the amplitude. That's this number, not negative 1/2. Amplitude is 1/2. To go up 1/2, so we'll have 3 pi over 2. 3 and 1/2 is 7 halves. And here, we're going to have negative 3 pi over 2. We're subtracting a half from 3, so that's 5 halves. And here, we have 9 pi over 2. And this is y equals 3. We're going down a half. And so this is 5 halves. So there's our cosine version. Step 2, where secant was equal to 0, drawing vertical asymptotes. And the last step, draw in paraboloids. Why are they paraboloids and not parabolas? Well, parabolas get wider and wider as they go higher and higher. And this doesn't. This just goes higher and higher because of these two bounding vertical asymptotes. Don't forget these bits. We've got this one over here and this one over here. Now, just to think for a moment about this. I don't want anyone thinking that I think the black thing is part of the graph. The black thing was just a graphing aid, a graphing assistance. My graph is the red graph. The red graph is secant. Now, let's talk for a moment about what this would look like if we did 2 periods. I think I want you to see something. Okay? So we had negative 3 pi over 2, and we have 9 pi over 2. So, if I set this argument, x over 3 plus pi over 2 equal to 4 pi. 4 pi? No. Yes, 4 pi, second period. So we're going to have x over 3 equals, this is 8 pi over 2 minus 1 pi over 2 is 7 pi over 2. Or 21 pi over 2. 21 pi over 2. So the distance here is 12, and the distance there is 12. Okay. So I want you to see something. Okay, so here we are. This is negative 3 pi over 2. This is one period ending at 9 pi over 2. And at 21 pi over 2, the second period is ending. So halfway across each period, 3 pi over 2, and halfway between these is going to be 15 pi over 2. And now we need our quarter points. So that was at 0, 6 pi over 2. This will be 12 pi over 2. And this will be 18 pi over 2. We're sketching in our negative cosine. Here, 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 here. Okay, and wherever the cosine version is equal to 0. We've got that. Okay, and let's draw in the paraboloids. Now, do you notice anything different between us graphing 1 period and 2? So that's a period. That's a period. That looks like cosecant. When we first drew just 1 period of secant, we had an up, and in between down. And this is half a period, a quarter of a period, a quarter of a period. And they all add up to 1 period. 1 period of secant. But if I'm doing cosecant, which is coming from a sine graph, I don't have just 2 vertical asymptotes in that 1 period. I have 3. And I get 2 complete paraboloids. 1 up, 1 down. Okay. So, hey, look, that looks just like cosecant graph. And that's because just like sine and cosine are cofunctions of each other, i.e. you transform one of them and it turns into the graph of the other one. The same thing holds true with secant and cosecant. So with 1 period, you're going to see cosecant have 1 complete up and 1 complete down. But if we're looking at secant and just 1 period, we're usually going to see 1 up and 2 halves down, or 2 halves up and 1 down. Okay, so watch out for that. That can sometimes be helpful. In fact, let's have you graph this cosecant. Y equals 2 cosecant 3x plus pi over 3 plus 1. Alrighty. Take a couple moments to graph that. And when you're feeling comfortable with this, we'll move on to graphing tangent and cotangent. Okay, welcome back. 3x plus pi over 3 equals 0. 3x plus pi over 3 equals 2 pi. 3x equals negative pi over 3. X equals negative pi over 9. This is 6 pi over 3 minus 1 pi over 3 is 5 pi over 3. And so when we divide by 3, we get 5 pi over 9. So my graph, negative pi over 9, 5 pi over 9, halfway in between, 2 pi over 9. And because negative 1 plus 5 is 4, so we're going to have 4 pi, double the denominator, over 18, which reduces to 2 pi over 9. I like 2 pi over 9 because now I have common denominators. I can add the numerator and double the denominator. I can add the numerator and double the denominator. Okay, we're doing cosecant and it's positive cosecant, so I'm starting with a positive sine graph. And remember, wherever this sine graph is touching our sinusoidal axis, y equals 1, we want to draw in a vertical asymptote. And the last thing, well, I want to draw in those paraboloids, but please don't forget to label that point and that point. We know the x value is pi over 18, but what about the y value? Well, our sinusoidal axis was 1, and our amplitude was 2. So 1 plus 2 gets into 3. And for this one, I'm at y equals 1, and I go down 2. So I'm going to have 7 pi over 18 minus 1. Because we went down 2 from 1. Nice. Okay. So if you're comfortable graphing sine and cosine, I don't think cosecant and secant are that much further, that the difficulties in graphing are not that very large. Okay, so let's think about tangent and cotangent now. So with tangent and cotangent, I kind of want to do the same thing we did with sine and cosine. Tangent theta, got negative pi, negative 3 pi over 4, negative 2 pi over 4 is pi over 2, negative pi over 4, 0, positive pi over 4, pi over 2, 3 pi over 4, and pi. I know it's a whole bunch of stuff. You know, I still remember when I learned to do these, we had to do this for every problem. Wow, did that suck? No wonder I failed math twice. Okay, tangent of negative pi. Well, what's the ordered pair at negative pi? Negative pi is this angle. Oh, the ordered pair here is negative 1, 0. Okay, tangent is y over x. So 0 over negative 1, that's 0. Negative 3 pi over 4. Well, negative 3 pi over 4, I'm going to here. What's the ordered pair here? Negative root 2 over 2, negative root 2 over 2. And so when we divide this one by this one, we get 1. Okay? Let's plug in now this ordered pair, which is 0, negative 1. This is negative pi over 2. And negative 1 over 0. Do not leave your answer like that. Shame on you. Just like this, don't leave your answer like this. You know what that tells me? That tells me I should mark this wrong because you're not sure that this is 0 and that this is undefined. Even though we've talked about that. Come on, you need to own this knowledge. So when I plug in a negative pi over 2, I get undefined. And for us, that's going to be a vertical asymptote. If we plug in negative pi over 4, we're talking about this angle now, and that's going to be negative root 2 over 2 over positive root 2 over 2, which is negative 1. If I plug a 0 in, if the ordered pair here is 1, 0, the y value over the x value, oh, that's 0 over 1 is 0. Cool. If I plug in a pi over 2, I'm going to get positive 1. I'm sorry, a pi over 4 gives me positive 1. A pi over 2 is going to be me putting in 0, 1. This over this, it's undefined. Ooh, another vertical asymptote. If I put in 3 pi over 4, I get negative 1. And if I plug in pi, what happens when I plug in pi? Well, the same thing that happened when we plugged in negative pi, because the ordered pair is the same. And we get 0. Now, does this appear to be a periodic function? Does it go through the same pattern? We went 0, 1, undefined, negative 1, 0, 1, undefined, negative 1, 0. Yeah. And so what do I notice about this pattern? Well, it seems that this distance from negative pi to 0 isn't 2 pi, like it would be for sine or cosine or secant or cosecant. It's only pi for tangent before we start repeating ourselves. And look, from 0 to pi is that sort of next round of repetition, and that's also a period of pi. Well, let's graph what we've got here. Let's see what we've got going on. Okay, here's 0, here's negative pi, here's positive pi. Okay, cut that in half, and we're going to have negative pi over 2 and pi over 2. And we've got these quarter points. Negative 3 pi over 4, negative pi over 4, pi over 4, and 3 pi over 4. So I've got an x-intercept here and a vertical asymptote here, and an x-intercept here and a vertical asymptote here. Okay. And now check it out. Between negative pi over 2 and 0, we have negative pi over 4, and the y value there is negative 1. So negative pi over 4, negative 1. And over here, between 0 and pi over 2, that's us using pi over 4. And so at pi over 4, we have a value of 1. And so there's my graph of tangent. Well, that's one period of tangent. If we wanted 2 periods, remember we said the period was pi. So when we go from negative pi to positive pi, that's actually 2 cycles. Here's one of them. Here's half of another one. Sorry, I wanted these y values to be similar. This is negative 3 pi over 4, 1. And then over here, when we plug in 3 pi over 4, 3 pi over 4 gives us negative 1. So our graph looks something like that. And here is 3 pi over 4, negative 1. Okay, this is 2 periods of tangent. If I want just 1 period of tangent, I could go from 0 to pi or negative pi to 0, but neither of those became the standard. Instead, what became the standard was going to from vertical asymptote to vertical asymptote. And so we're going to talk about this. This is our reference graph. 1 period. 2 periods? No problem. We could do that too. Right now we have 1 period. 1 period finds itself completely between vertical asymptotes. That's a nice kind of bounding thing about this. Oh, one other thing. Between this class and calculus, we're just not gonna graph many tangent and cotangent things. And certainly in calculus, no, not really. So what I'd like to say is, let's make this a little easier on ourselves. Ready? Let's not worry about those quarter points. Instead, let's just graph the vertical asymptotes and the intercepts. Well, sinusoidal axis intercepts. That's it. That's all I'm going to draw. There's my graph. Now, if we get rid of quarter points, that does come at a cost. And the cost is anything like y equals 2 tangent x minus 1 over 3 plus 4. I guess I want so here's, I've got all my transformations. Well, it turns out if we don't have quarter points, this number is meaningless to us. The way I would find these, the y values for these quarter points, was I'd start with my sinusoidal axis, and I would go up 2, and I would go down 2 from those quarter points. So we can do it, and you're more than welcome to if you like. But yeah, no, I'm sorry. I'm just not going to worry about that. So I'm really not going to worry about my a value. Now, that being said, if there's a minus in front, I'm not ignoring that minus. I'm ignoring the 2, but the minus gives me this shape. Yeah, and so, no, I can't throw the minus away. But I am going to throw that 2 away. Okay, no amplitude to worry about here. Watch out for the negatives. Okay, so then what is our protocol going to be for graphing a tangent graph? Well, 1 period fits between vertical asymptotes at negative pi over 2 and pi over 2. Fabulous. So I'm going to start with y equals tanx. And I'm going to say, step 1, set what's in the parentheses. Now this time, not equal to 0 and 2 pi, like we did for sine and cosine, and therefore secant and cosecant. But here we're going to set the argument equal to negative pi over 2 and positive pi over 2. And so what we're going to be doing is we're going to be finding where the vertical asymptotes are. Nice. And then I think we're just going to draw in the vertical asymptotes. 3, find the halfway point, and 4, draw in our shape. Okay, so what do I mean by this? Well, let me show you. If I have something like y equals 4 tangent x over 2 plus pi over 4 plus 7. Okay, can't imagine anything worse than that. All right, I'm going to start by setting the argument x over 2 plus pi over 4, not 0, negative pi over 2 and pi over 2. Okay, that's negative 2 pi over 4 minus 1 pi over 4 is negative 3 pi over 4. And then I'm going to multiply both sides by 2. So I get negative 3 pi over 2. And x over 2 plus pi over 4 equals positive pi over 2. Well, when I subtract pi over 4 from 2 pi over 4, I get pi over 4. So over 2. X equals pi over 2. All right, so our graph is going from negative 3 pi over 2 to positive pi over 2. Negative 3 pi over 2, positive pi over 2. Halfway between is negative pi over 2. Good. Draw in your vertical asymptotes, and then sketch in the shape for tangent, which kind of looks like, but isn't, y equals x to the third. With y equals x to the third, this point is different. We have a 0 slope on y equals x to the third at x equals 0. Here, no, the slope turns out to be 1. I believe it turns out to be 1, but not 0, like it is for y equals x to the third. All right, well, that's it. That's the whole graph. Oh, wait, I've got to label the y value, right? Because this is y equals 7. So, 7. There we go. No quarter points to worry about. If I wanted quarter points, I'd go halfway in between these, and then this 7 plus 4 gives me 11. And that's also known as the y-intercept. And then over here at negative pi, we would have this other point where we were 7 and went down 4 to 3. So yeah, if you want, you're welcome to label those quarter points, but I say don't bother. It's not worth it. We really, sine, cosine graphs, oh my god, you have to know those really, really well. And in fact, I don't use secant and cosecant a whole lot in calc. So why do we do those? Because it gives us more practice graphing sine and cosine, and you really need to do that in calc. Okay, so how about you? Is it time? It's time. Please graph this one. Y equals negative 2 tangent pi x plus pi over 2 plus 3. Okay. I'm interested to know, before you pause this, I'm interested to know what you set your argument to. Hey, welcome back, everyone. So we've got pi x plus pi over 2 equals negative pi over 2, and pi x plus pi over 2 equals positive pi over 2. Remember, non-zero and 2 pi, like sine, cosine, secant, and cosecant, negative pi over 2, positive pi over 2. So if I subtract pi over 2 from both sides, I have pi x equals negative pi. And if I divide both sides by pi, I get x equals negative 1. When I subtract pi over 2 from pi over 2, I get 0. So pi x equals 0. And when I divide both sides by pi, I get x equals 0. So my period goes from negative 1 to 0. Got my vertical asymptotes. We know that halfway in between 0 and negative 1 is negative 1/2. And the y value here is our sinusoidal axis value, that 3. Cool. So why does this get marked wrong on the test? Good eye. Nice. Because of that negative. I have to multiply all these y values by negative 1. So that's our graph. That's right, and the only thing I need you to label are the vertical asymptotes and this inflection point, where we go from concave up to concave down. And that was at negative 1/2, positive 3. Again, if you want to use the amplitude and you want to take the time to find the quarter points and plot those points as well, you're welcome to. But I'm going to discourage it. All right, so that's graphing tangent. Now, cotangent. Remember that cotangent is 1 over tangent x. And remember that long list of tangent values we had? Okay, and at negative pi, we plugged in a negative pi, and we had 0. And we had negative pi over 2, and that was undefined. And we had 0, and that was 0. And we had pi over 2, and that was undefined. And we had pi, and that was 0. Yeah, these were our tangent values. Well, if cotangent is the reciprocal of this, what will our cotangent values be? So when tangent is 0, 1 over 0 is undefined. And if tangent is equal to 1 over 0, actually I think that was negative 1 over 0, and I flip that upside down, I'm going to get 0 over negative 1, which is 0. And here I'm going to get undefined, and here I'm going to get 0, and here I'm going to get undefined. That means wherever tangent is equal to 0, cotangent has a vertical asymptote. And where tangent has zeros, where tangent has vertical asymptotes, cotangent has zeros. Well, isn't that interesting? So let's take a look at negative pi, 0, and pi. We've got vertical asymptotes at each of these places. Nice. And we have inflection points here at negative pi over 2, and here at positive pi over 2. Good, nice. And what about drawing in the shape? Well, that's really interesting. So let's go back and look at this point, negative pi over 4. So with negative pi over 4, our tangent value was negative 1. Well, negative 1 over 1 is still negative 1. So I get this point, negative pi over 2, negative pi over 4, negative 1. Uh-oh. See, I was expecting it to go like this, just like tangent did. No. No. It goes like that. And again, here. So here's 2 periods of cotangent. 2 periods of cotangent. This is 1 period, this is 2 periods. And it's true. The shape of our cotangent graph is exactly that of negative tangent graph, right? We're multiplying all the y's that would have been going like this by negative 1 to flip them to be this. Fabulous. Now, I do want to have a word of caution. When we graphed tangent, we said set the argument equal to negative pi over 2 and pi over 2 to find vertical asymptotes. But cotangent? No, cotangent doesn't have vertical asymptotes at these places. Cotangent has vertical asymptotes. Set argument equal to 0 and pi. Now I will say that some of you are hearing my words right now, and many of you are not taking these words seriously enough. Big mistake on the next CFA, big mistake on the next quiz, big mistake on the next test is that people either forget about these or both. Okay? You've got to know them all. You know, it may well help to make this little table. We want trig function sine x and set argument equal to what? 0 to pi, 4 pi if you're doing 2 periods. Cosine, yeah, I agree, 0 to pi, 4 pi if you're doing 2 periods. Cosecant, well, the first thing I do with graphing cosecant is graph sine, so same. And secant, yep, same. But once we get to tangent, things are different. We have negative pi over 2 and positive pi over 2, and if we needed a second period, we would use 3 pi over 2. The distance from here to here is pi, the distance from here to here is pi. We know that the period for tangent is pi. And then for cotangent, we don't use these. We use 0, pi, and 2 pi. Okay? So you must know these, or you will bomb. Oh my goodness, this shows up on the final exam too. Because we've got that graphing problem to deal with. Okay. So, how about we graph one or two tangent or cotangent things? How about y equals tangent pi over 2x plus pi over 3 plus 2. Okay, pause the video, give this one a try. Yes, you're going to have to be careful when working with that. Yes, you will need to make common denominator. Hey, welcome back. So what did you set your argument equal to? Did you set your argument equal to negative pi over 2? Hope so. So I'm subtracting pi over 3. Well, in order to do this, Mrs. Rowan told me in the 7th grade that I need to make a common denominator. So that common denominator is going to be sixths. I multiply here by 3 over 3. That gives me negative 3 pi over 6. And here by 2 over 2. And that gives me negative 2 pi over 6. So that's negative 5 pi over 6. I have a vertical asymptote at x equals negative 5 pi over 6. Great. Now, for the second vertical asymptote, what do we use? We use negative pi over 2 for the first one, and we use positive pi over 2 for the second. I'm still going to subtract pi over 3 from both sides. And so that's, whoa, did I double? I don't think I took care of that. Yeah. Let's fix that first. Okay, so this is negative, and this is negative, and we've got pi over 2x equals negative 5 pi over 6. Thought I missed that. Times the reciprocal. These cancel. These cancel. So x equals negative 5/3. Oh, that's very good. Yeah, good to be thinking about what you're doing. So now we're going to do positive pi over 2. And that's going to get us pi over 2x equals 3 pi over 6 minus 2 pi over 6 is 1 pi over 6. And if I multiply both sides by 2 over pi, I'm going to get x equals this cancels this here, 1/3. Okay, so negative 5/3, 1/3, halfway in between, negative 2/3. Draw on your vertical asymptotes. It's a positive tangent. And please make sure you label the inflection point. This sinusoidal axis is y equals 2, and so that's why my y value there at that halfway point is y equals 2. Any questions about this? Okay, how about a cotangent? Y equals cotangent x over 3 minus pi over 4. I'm doing a lot of pluses. Let's do minus 5. So what was it that I was supposed to set the argument equal to here? Good. X over 3 equals, x over 3 minus pi over 4 equals 0. And x over 3 minus pi over 4, not 2 pi, 0 and pi. The period for tangent and cotangent is pi. Okay, so finish from here if you haven't finished already, and we'll go on. Okay, so I solve. That's going to give me x over 3 equals pi over 4. And if I multiply both sides by 3, I get x equals 3 pi over 4. Here's 4 pi over 4 plus 1 pi over 4. It's going to be 5 pi over 4. And so we get x equals 15 pi over 4. So these are where my vertical asymptotes are going to be. Great. 3 pi over 4, and we have 15 pi over 4. Why are these so far apart? Because of this. This has me multiplying x's by 3. This is a horizontal expansion. So let's graph what we know. We have 3 pi over 4 and 15 pi over 4 as vertical asymptotes. And halfway in between 3 and 15 is 9 pi over 4. Sure, add these. 3 plus 15 is 18. Double the denominator. 18 pi over 8, which reduces to 9 pi over 4. 9 pi over 4. Okay, and what about the shape? Is it this? No. It's cotangent. Cotangent's shape is like that. Of course, if we had negative cotangent, we'd draw this. Negative cotangent looks like tangent, except the vertical asymptotes are in the wrong place because we've shifted to make cotangent from tangent. And negative tangent looks like cotangent does. Okay? I do want you to label that ordered pair. I do want you to tell me that, yeah, we shifted up. So that even though I'm not labeling the quarter points, I still want this as an ordered pair. I want the inflection point as an ordered pair. We are often in calculus going to be concerning ourselves with inflection points. So, yeah, I need that ordered pair. Okay? Well, there you go. That's graphing tangent and cotangent, secant and cosecant. I think you're good to go on all of these, and you'll be getting some practice soon with Mr. Pause on them. Take care, everyone.